Hey everyone, welcome to Ishwin Creations channel. Today we shall discuss the topic on analysis of variance. Just a few short notes on analysis of variance. So first, this technique, it is an extremely useful technique concerning researchers in the field of what? In the field of economics, biology, education, psychology, sociology, business or industry, and in researches of several other disciplines. This technique is used in these many fields. Okay. This technique is used when it is used, this technique, when multiple sample cases are involved. Okay. So when we use an analysis of variance, so when it is a multiple sample cases are involved. Okay. Next, means of two sample can be judged through either Z test or the T test. Okay. Means of two sample. Here next, Professor R.A. Fisher was the first man to use the term variance, developed a very elaborate theory concerning, that is, analysis of variance, ANOVA. So ANOVA, it is a procedure for testing the difference among different groups of data for homogeneity. ANOVA, procedure for testing the difference among different groups of data for homogeneity. Between sample variance is due to different treatments. Within sample variance is due to random unexplained disturbance. Next, F equation. So F equals to between sample variance divided by within sample variance. So that is equals to MS between divided by MS within. So MS between can be written as again SS between divided by K minus 1. So SS between means we need to calculate like this: N1 x1 dash minus x double dash whole square plus N2 x2 dash minus x double dash whole square plus it is continued till nk xk. Okay, till it continued. Next, k is samples. K minus 1 is nothing but a degree of freedom between samples, and SS is a sum of squares. Okay, SS within means SS within formula is summation x1I minus x1 dash whole square plus summation x2I minus x2 dash whole square plus it is continued till xki minus xk dash whole square. I equals to 1, 2, 3. MS within equals to SS within divided by N minus K. Now we shall see the some problems, simple problems. Given below is a summary of ANOVA for 4 group of students tested in a research project. They have given like this: between groups, within groups, and sum of squares, DF, that is degree of freedom value also they have given, and mean sum of square value also they have given. They have asked to find out what? They have asked to find out the value of F. F equals to what? MSB divided by MSW. We know here MSB, that is between groups, 23.33. So MSW, that is within groups, 7.62. That is the answer. Okay. Next problem. An investigator used ANOVA to compare 4 groups of students on numerical ability on the basis of a test. After analysis of raw score, the following results were obtained. So they have given like this: source of variation between groups, within groups, and DF value, degree of freedom value they have given, sum of square value also they have given. They have not given the mean sum of squares. MSB value, okay, MSB, sum of squares divided by DF. Okay, here MSB equals to SSB divided by DFB. Okay, that is what we have done here. Similarly for MSW. So after getting these values, F equals to MSB divided by MSW. That value is 3.52. That is the answer. So next problem, the following data is given by, so type of animals, dog, cats and hamsters they have given. Number of animals 555 and average domestic animals they have given like this, and the standard deviation also they have given. Calculate the ANOVA coefficient. Okay, first we need to make list like this. Okay, animal name, dogs, cats and hamsters. N is a number of animals what they have given, that is the n. Okay, x is nothing but average domestic animals what they have given, that is the value of x average. S is a standard deviation what they have given, that is a s square. Okay, s square means 2 square, 1 square, 4 square, that is what we have written. Next, p equals to, okay, p equals to 3 because here 3 category are there. So what is a p? Total number of population. Okay, so here 3 category are there. P equals to 3, n equals to 5. Okay, here n equals to 5 and the capital N, so 5 plus 5 plus 5, that is a total 15. X dash, okay, that is total average. Okay, so 12 plus 16 plus 20 divided by 3 if you do, you will get 16. So that is the answer. Okay, x dash. Next, SST equals to summation n open bracket x minus x dash whole square. Okay, so what is the value of n here? 5, and the x value is 12 minus x dash value is 16 whole square. Similarly, you need to consider for 16 and also 20 x value. Next 16, next 20. Okay, so overall SST value you will get 160. Next MST. Okay, MST equals to SST divided by P minus 1. So P is, here we have written that 3 minus 1. So SST value is 160 divided by 3 minus 1, you will get 80. Now we need to find out the SSE. Okay, here different case it is. So MST divided by MSE formula. Okay, SSE equals to summation n minus 1 whole bracket s square. So SSE equals to 4 into 5 minus 1 plus, so again 5 minus 1 into 1 plus 5 minus 1 into 16. Okay, so what you will get, the value is 84. So we need to consider n value 5, it is common for all, the only change is s value. Okay, s value for cat and dog and hamsters it is different. Okay, 4 and 1 and it is 16. Next MSE. Okay, MSE equals to SSE divided by n minus p. So we know that SSE value 84 and we got n value is 15 and p value is 3. Yes, you will get 7. So 80 divided by 7 equals to 11.429. This is the value of f. Some other formula, that is x double dash means x1 dash plus x2 dash plus x3 dash plus till it is continued xk dash divided by number of samples, that is k. And the next one is analysis of variance is statistical method of comparing the means of several population. This is a MCQ question. Analysis of variance is a statistical method of comparing the means of several population. When conducting an ANOVA, F data will always fall within what range between 0 and infinity. And next, the formula of correction factor equals to t square divided by n. What is a t? It is a total of observations in all the samples. Next problem. This is a simple problem. Set up an analysis of variance table for the following two-way design result. So they have given variety of fertilizers, that is W, X, Y, Z. Okay, and they have given 3 A, B, C variety of seeds. Okay, so they have given the values. So here also state whether variety difference are significant at 5% level. Okay, this is the question they have asked. So first we need to find out what? First we need to find out T. This is a two-way design. Okay, add all this, so you'll get the T value is 60 and N they have given that N 4, that is, so here a variables 1 2 3 4, again 1 2 3 4, okay, this a b c, okay, so 4 plus 4 plus 4, so n value will become total 12, okay. Correction factor equals to t square divided by n, so that is a t square divided by n, you will get 300. Next to total ss, so total ss is here overall whatever you have added 6 square, that is 36. Total ss means sum of square, so what you will do, 6 square, again they have taken row wise, okay, 6 square, 5 square, 5 square plus 7 square, 5 square, 4 square, overall this all values we need to do the square, minus 60 into 60 divided by 12. So what is the formula here? Total ss equals to xij square minus t square divided by n, that is the formula, okay. So when you do that, overall square minus t square divided by n, so you will get the value is 32. Next, ss between columns treatment, so between columns means here 6 7 3 8 like that, okay. So now you can see here 6 between columns, so overall this how much you will get, 24, okay. Overall if you add this one 24 you will get, okay. So 24 into 24 divided by 4, again next you can add here, okay, 10, again 20, okay. So b, if you add total b, so you will get 20, if you add total c you will get the 16. So 24 into 24 divided by 4 plus 20 into 20 divided by 4 plus 16 into 16 divided by 4 minus t square divided by n. So what is the formula here? ss between columns treatment equals to summation tj square divided by nj minus t square divided by n. So if you add this, if you solve this, you will get the value is 8. Next, ss between rows treatment. So rows treatment means you need to add like this, okay. So 5 plus 5 plus 6, 16 like that, okay. So 16 into 16 divided by 3 plus, so divided by is ni, ni means that is rows 1 2 3, okay. When you consider the column wise w x y z, so we have done divided by 4 here, so here a b c parameters, that is divided by 3, same you need to substitute and calculate, so you will get the value is 8. So ss residual are error, ss residual r error equals to total ss minus ss between c plus ss between r, that is equals to 32 minus open bracket 8 plus 18 close bracket, that is the value is 6 you will get. Some points regarding variance. Total variance, that is between sample variance, is due to different treatments. Within sample variance is due to the random unexplained disturbance, okay. This I told in the beginning only. Between sample variance is large when the effect of all the treatments are different. So between sample variance is large when it will be large when all the effects, when the effect of all the treatments are different. In such case the computed FC is large and we are likely to reject the null hypothesis. Therefore this test is a right-tailed test, okay. This is important. If they ask in a MCQ question, they may ask regarding this. So between sample variance is large when the effects of all the treatments are different. In such case the computed FC is large and we are likely to reject the null hypothesis. Therefore this test is a right-tailed test, okay. Next, the formula of critical difference for each pair of treatments, that is square root of ms within square root of ms within open bracket 1 divided by ni plus 1 divided by nj close bracket into k minus 1 into f suffix k minus 1 comma n minus k comma a. Latin square design. So what is a Latin square design? It is an experimental design used frequently in agricultural research. So it is a variance between columns, variance between rows, variance between varieties, residual variance, different 4 types. Okay, in this Latin square design you will get the 4: variance between columns, variance between rows, variance between varieties, and residual variance. So next is while applying the analysis of covariance technique, the influence of uncontrolled variable is usually removed by simply linear regression method. So while applying the analysis of covariance technique, the influence of uncontrolled variable is usually removed by what? Removed by a simple linear regression method, and the residual sum of squares are used to provide what? Residual sum of squares are used to provide variance estimates, which in turn are used to make test of significance. Analysis of covariance technique requires one to assume that there is some sort of relationship between the dependent variable and the uncontrolled variable. We also assume that this form of relationship is the same in the various treatment groups, and various treatment groups are selected. How they select the various treatment groups are selected random from the population. The groups are homogeneous in variability. The relationship is linear and is similar from group to group. So this is just few points on analysis of variance, and some important formulas also I have mentioned. So thank you for watching. Subscribe channel for more updates.